Hi guys, back with me again, Aki Kurniawan Yusuf. In this video, I want to share to you how to conduct two-sample hypothesis testing using SPSS. In the previous video, I have explained about what is two-samples hypothesis testing. In two-samples hypothesis testing, we would like to compare two different data. It can use independent samples or dependent sample. Independent sample if we would like to compare two different samples. For example, male and also female, CTA and also CTP. While for dependent sample, we would like to compare the same sample in two different conditions. For example, before and after training. So in the dependent sample, the number of samples will be the same because you use the same sample. In this video, I want to share to you how to conduct two-sample hypothesis testing using SPSS. The test you can do in the SPSS is only t-test either for one tail or two tail. And you need to have the complete data to conduct the test. If you only have the data of the sample standard deviation about the sample mean without knowing the data, you cannot run the analysis. I just want to review you about one tail versus two tail test. In the two tail test, you only want to know whether there is any difference between two sample mean. Only is there any difference, no particular direction. However, if you want to find whether the mean of sample A is higher or lower than the mean of sample B, you have to use one-tail test. One-tail test has more power compared to the two-tail test. So, let's start. I have the data of the house price in $1,000 in the Antonio City and also in the River City. I want to know whether there is any difference between the mean of the house price in the Antonio City and also River City. So we can use two-sample hypothesis testing. We don't know the population standard deviation, so of course we will use t-test. To conduct t-test in the SPSS, we cannot use this kind of table form. However, we have to put each variable into one column. For example, the name of the variable will be house price and city. So for the Antonio, I will copy it first here. The city, I symbolize it with 1. So 1 is Antonio. And then I copy the house price in the River City and code it with 2. So 2 is the River City. Okay. Let's go to the SPSS. In the variable view, this will be house price and then this will be city. Both are numeric. For the label, I will use house price and also city. And I put values here. 1 is Antonio and 2 is river. Okay, for the measure for the house price, yes, it is scale. For the city, it is nominal. Right? We cannot rank in the order Antonio or river, and it is actually the categorical variable. So we go to data view and then we copy the data from the Excel. Copy, then paste. Now we will analyze two-sample hypothesis testing in SPSS. This is the way. Analyze, compare means. Okay. You have to determine whether the sample is independent or dependent. We want to compare the mean of the house price in the Antonio City and also River City. Of course, the sample of these two data are different. One in the Antonio City and the second one is in the River City. So it is independent sample. Therefore, we use independent sample t-test. Just click this. The test variable will be the house price because we want to compare the house price. The grouping variable, we want to compare Antonio and also river, right? Based on their city. Therefore, city is inputted in the grouping variable. We click define group. Group 1 is 1. Yes, it is Antonio, right? Group 2 is 2. We have coded 2 as River City. Then continue. Okay, and then okay. We can see here in the group statistic that Antonio City house price mean is 412.3750, while for River 334.6471. The mean of the house price in the Antonio City should be higher than the River City based on this group statistic. But whether there is any difference or not, we have to use hypothesis testing. Now let's see in this independent sample test. There are two types here, equal variance assumed and equal variance not assumed. You have to test the standard deviation or variance using ANOVA. But if you haven't learned about ANOVA, just use the rule of thumb. If the higher standard deviation compared to the lower standard deviation is less than 2, we assume equal variance assumed. But if it is higher than 2, we assume equal variance not assumed. We can see here the standard deviation, the higher one 123 something, the River is 29.7 something. If we calculate 123.79762 divided by 29.78242, it is 4.15. Therefore, we choose equal variance not assumed. If it is equal variance assumed, you see the first row. If equal variance not assumed, you see the second row. Okay, so we focus on the second row. How to interpret the data between these two rows will be the same. This is the T calculation. This is the DF. As you know, if it is equal variance assumed, the DF will be N1 plus N2 minus 2. So the total samples for both data minus 2. Well, for equal variance not assumed, the DF use the complicated formula. Comparing the T calculation here with the T critical will be more complicated because we have to find the T critical. Therefore, the easiest way is that we use p-value. We can find the p-value in sig-2 tilt. It is the p-value for 2 tilt. You have to remember in this session we analyzed 2 tilt tests. Okay, we see here the sig-2 tilt, it is 0.026 or 2.6%. To know whether we should reject or should not reject XO, we see from the p-value. If the p-value is higher than alpha, we should not reject XO. If it is lower than alpha, we should reject XO and accept H1. For example, we determine the significance level is 5%. Therefore, this value, the p-value 2.6% is lower than 5%. So the conclusion is that reject XO and accept H1. It means the mean of the house price in the Antonio City is different to the mean of the house price in the River City. This is the shortcut for 2 tilt tests. If the p-value is less than alpha, there is any difference. One more time, if p-value is less than alpha, there is any difference. On the other hand, if the p-value is larger than alpha, there is no difference. Is it clear, right? How if I give the direction in the question? Is the mean of the house price in the Antonio City higher than the mean of the house price in the River City? So the XO will be mu Antonio is less than or equal mu River. While for the alternate hypothesis, the H1, mu Antonio is higher than mu River. This is one tail test. How to conduct one tail test in the independent sample t-test? The steps is the same and the result will be the same as well. So in this case, we also use equal variance not assumed. One thing that you need to pay attention, if you want to conduct one tail test, the p-value here is only for 2 tail. The sig here is only for 2 tail. Therefore, in the one tail test, to find the p-value, you have to divide the sig-2 tail by 2. This is 0.026. If it is divided by 2, it becomes 0.013. This is the p-value of one-tailed test. The 0.013 is less than the significance level, which is 0.05. Therefore, we should reject HO and accept H1. We can conclude that the mean of the house price in the Antonio city is higher than the mean of the house price in the river city. I will give you the shortcut as well, as I ever mentioned in my previous video. If in the two-tailed test, the result is there is any difference, in the one-tailed test, the result will be higher or lower. If in the two-tailed test, the conclusion is there is any difference, in the one-tailed test, the conclusion will be higher or lower. So in our previous two-tailed test, the conclusion is there is any difference. Therefore, in this one-tailed test, the result will be higher or lower. And it is proven that the mean of the house price in the Antonio city is higher than the mean of the house price in the river city. Is it easy, right? Now, let's try dependent sample t-test. So I have the data about English score before training and after training. I want to know whether there is any difference in the English score after training and before training. This is the hypothesis. Since the keyword is difference, so the HO will be mu after equal to mu before. The alternate hypothesis or H1 will be mu after is not equal to mu before. Or I can rearrange the equation, it becomes for HO, mu after minus mu before is equals to 0. And for H1, mu after minus mu before is not equal to 0. Mu after minus mu before can be symbolized with mu d, the mean difference. For dependent sample t-test, we don't need to rearrange the table. We just use before and after like this. So we go to SPSS. The variable view, we can fill score before and score after. Okay, we can give the label, this is before, this is after. And both measure will be scale. Alright, now let's copy the data. This is the data we copy, input it into SPSS. In the data view, paste. Alright, this is the step. Analyze. Compare means we choose pair sample t-test. So dependent sample t-test is the same with the pair sample t-test. Since we want to compare after and before, right? After minus before. So the first variable will be after. Input it here. Okay, and then the second one will be before. Alright, now okay. This is the result. The pair sample statistics shows that the mean after is higher than the mean before, right? But we have to test it using hypothesis testing. This is the result in the pair sample test. The sig-2 tilt. You can see here the DF is 7. For pair sample t-test or dependent sample t-test, since they have the same number of sample, so the DF is only the number of sample minus 1. Not 8 plus 8 minus 2, not like that, but 8 minus 1, it is 7. Okay? Again, we need to compare the p-values to know whether we should not reject or reject the HO. This is the p-value for two-tail. We can see here that the p-value for two-tail is 14.6% or 0.146. It is larger than the significance value. If the p-value is higher than the significance value, we should not reject HO. Therefore, we can conclude that the mean after training is not different with the mean before training. So, we can say that the training is not effective yet, right? How if I change the question into one-tail task? Is the score mean after training higher than the score mean before training? The steps will be the same. You use analyze, compare means, pair sample t-test, and the result will also be the same. We need to compare the p-value of one-tail test since the question is higher. The keyword here is higher. Therefore, the HO will be mu after is less than or equal mu before, or I can write mu after minus mu before is less than or equal to 0, while the H1 will be mu after is higher than mu before, or mu after minus mu before is higher than 0. The step will be the same: analyze, compare means, pair sample t-test, and the result will also be the same. The output will be the same. To know whether we should reject or should not reject the hypothesis, see the p-value. But again, seek two-tailed is p-value for two-tailed. How to find the p-value for one-tail? Divide the seek two-tailed by 2. 0.146 if we divide it by 2 become 0.073 or 7.3%. 7.3% is higher than the significance level 5%. Therefore, we should not reject HO. Or we can say that the mean of the score after training is not higher than the mean of the score before training. It strengthens the argument that the training is not too effective because the score after training is not higher than the